Hi, Stefano. Welcome to the Autoware podcast. You're our third guest for the software-defined vehicle themed podcast, and we really enjoy having this conversation with the important stakeholders. So, although probably everybody knows you, but give us a quick understanding of who you are and what you're doing.
Of course, hello Samet and hello everybody. Stefano Marzani here from Mountain View, California. I work for Amazon Web Services and I'm the worldwide tech leader for software-defined vehicles for AWS. I work in the automotive and manufacturing business unit. 3.5 in. Before that, I spent my career in automotive, more than 20 years, working on several parts in the car. So from HMI. So yeah, nice being here. Thank you
It's
for the
great to
invite.
have you. And you are here to kind of celebrate also Amazon Web Services. Just recently joined Autoware Foundation. It's great to have AWS within the ranks of Autoware. We've been working together for some time between the Autoware and AWS, and that's nice. And we are looking forward to collaborating with you.
Absolutely. It's let me say that under the radar, it's more than 2 years that we are working with the with the Autoware Foundation. We hosted at least two hackathons in our offices here in Palo Alto, in East Palo Alto, and it's always been absolutely great. We believed since the beginning in the Autoware concept, right? So in AWS, we are big supporters of open source, open standards. We contributed to many projects, IoT Greengrass, FreeRTOS, and much more. Open standards, you know that we are very active in SOFI, we are very active in Eclipse SDV, we are very active in a lot of consortia. Our services use Covisa VSS, IoT Fleetwise. The co-development we did with NetBerry, Ivy, uses Covisa VSS. So we're strong believers. Autoware is just and we loved it because again with the OpenAD Kit initiative that we will discuss later on, it's really pure innovation that we are trying to put as a reference for the market. So it's a pleasure finally and formally being a member of Autoware, and yeah, it's a time to celebrate that for sure.
Perfect, perfect. Stefano, so we are going to talk about the SDV, of course, but before going into that, cloud is very important for automotive in general. So I tuned into several podcasts that you joined, and uh, give us an understanding why cloud is important for automotive. Some of the key takeaways I took when I listened to it was, on the AWS side, you have a good variety of cloud instances, different kind of technologies there, and also the elasticity. What I understood was very, very important to you. Let's talk a little bit about
Yes.
that one.
Yeah. Yeah, cloud is more and more important for automotive software development. That's really happening, and we see this transformation happening in the sector. There are a few very solid reasons for that. First of all, data. So our customers like BMW, for example, they collect a lot of data from vehicles in the order of terabytes and petabytes, and they store this data in AWS, in our Amazon S3 service, and form around it a data lake that will serve the entire organization. And the data has gravity. So when what do you use the data for? You use it maybe to create HD maps, like our customers here, or mobile, or you can create and you train deep neural networks, like our customer Toyota. And then you can use it to optimize powertrain performances through a simulation resimulation. And then you can use it so on, so on. So all these development processes, compute and data go together very nicely in the cloud. And the cloud is becoming, for this reason specifically, the tool that is used to develop more and more software that goes inside the vehicles as well. we are not 100% there because, and this is why we are working very intensively on software defined vehicles, because software defined means software first. So it doesn't matter if you develop it on cloud or on the physical device, right? That needs to be targeted for there. And as you correctly said, we have a lot of variety of instances and compute options in cloud. A very important one is Graviton, AWS Graviton, and we just announced last week at reInvent, the Graviton fourth generation Graviton. It's a processor that we started to produce since 2018, so it's already 5 years if you think about it. So the investment we did in this category of processors, and that's ARM based. ARM is the same architecture that is inside most of the cars out there. So we can really, and we are doing a lot of work to lift, as we say, lift and shift embedded software inside Graviton, leveraging this instruction set parity between the two environments. And there are a lot of variety of Graviton processor optimized for memory, optimized for performance with the GPU, if you need to have graphics and accelerated compute, and so on. So you say that the cloud is becoming that tool to develop software, like a Mac or a PC was the tool to develop application for the smartphone. So the cloud more and more is that tool to develop automotive software, like the Mac or the computer is for smartphone application.
I think that's a great segue because the software-defined vehicle is actually getting the inspiration from other software-defined industries, right? When we look at it, we
Yes.
want to use some of the modern software development methodologies bringing into the automotive. So I think that's a
Yes.
great time we dive into the SDV part a little bit, and I want to start with what values SDV will bring. I discussed with Robert and also Casper before. Some of the things they said was, once the vehicle leaves the factory or the dealership, it used to, if you want to update your software, you go to a dealership, and also that software is kind of like a baby software, right? It's not really kind of like ongoing improving the vehicle and everything. But now we can have actually vehicle, instead of depreciating, it can actually gain value over time. Let's talk about what do you think of the values will bring the SDV for everyone, for the automakers, for the consumers and everything.
Yeah. Let me start to point out that SDV, in my opinion, is the biggest revolution in the automotive sector since the introduction of the Model T. It's a big statement, but everything is changing in auto. So from the ground up and the very nature of the product. So electronic platforms are changing, ECUs are consolidating, we are towards electrification, consumer experiences needs to be at par with consumer devices, and so on and so on. Artificial intelligence, autonomous driving, all this is changing the nature of the product big times. We are really in a pivotal moment for the automotive industry. That this is what SDV is. Okay, so it's not just a software kind of thing. It's the software counterpart of a big revolution that is happening in the sector. So that's very important to be reminded. And we finally tackle some of the issues that the automotive industry had in the past 20 years. I always start highlighting that automotive and the car itself, it's still a very poorly tested system, because when you have 100 ECU in a modern car, cost optimized, from different vendors, maybe with 3 or even more CAN networks that connect them, how can you test that as a system? And in fact, the system coverage of a modern car with 100 ECU, let's say with all the architectures, is around 20%. That is a very low number. That's why we have so many recalls that cost billions of dollars every year to the industry, because the software is not tested enough. For structural reason, because of the combinatorial effect of this hardware-dependent system in a networking with such a complexity is not testable completely. So, and this need to be finally tackled, finally. And again, consolidation will help in that, because meaning less ECUs, more aggregated software, and this will increase quality, increase coverage, accelerate development, and so on. We start to have very significant data points because, again, we started to invest in SDV when SDV was not even a term. So 2 years and a half ago, we started to work with ARM. We presented the first parity architecture at ARM Dev Summit in October 2021. And so it was really, and at that time we were calling it Cloud to Edge because SDV was not a term yet. And in there, you really see, since then, we had customer adopting it. We presented a very important demo at CES 2023, so back in January this year, with the customer Marelli, that presented the first cloud-first components, an infotainment system that is first developed in cloud, and then later on you deploy on the hardware. Otherwise, it's not software-defined, by the way, because if you start with the hardware, it's hardware-defined. If you want a software defined, you start with the software, right? It's just kind of trivial kind of concept. And there's a very nice white paper that they release where they highlight 70%, 70% reduction in development time, 50%, 50 development in prototyping and R&D costs. So it's huge. It's huge saving in terms of time. And only if you achieve this simplification, better test coverage, acceleration of development, democratization of developments because you have nice APIs, you have virtual artifact you can distribute to a community of developers, you will generate that value that you were mentioning. So we are really, again, in a pivotal moment where we are really changing the structure of the industry in a way as an ecosystem. That's why we have all these initiatives, right? Sophie, Eclipse SDV, and we are so engaged in this transformation. So there's a lot of value there. There's a lot of value that is estimated in several billions, if not trillions dollars in the next up to 2030 in terms of projections from analysts.
Yeah. You mentioned some of the very, very important pillars, right? Because also when I first started to understand the SDV, Robert actually sent me a bunch of blog posts from ARM and AWS, talking about the cloud native part and the ECUs and the compute architectures are getting consolidated and everything. And there was very important thing there, right? The Autoware software development can actually start in the cloud because the compute you have in the vehicles with more or less the same architecture, they're also on the cloud side with the Graviton instances you have on the AWS side and also the Neoverse architecture on the edge. And talk to us a little bit about the environment parity. I think that's a very, very important point.
Yes, I think so too. And we see that really helping customers really to achieve these objectives of going faster and going, more, let's say, to achieve higher quality. So that's, and save costs, by the way. So it's surely relevant. It all started again with a very simple consideration. Most of the cars out there, vehicles in general, embedded systems in general, have an ARM processor. ARM is ARM64. That's the instruction set that is widely adopted in automotive. I think that more than 70% of the cars out there have for infotainment an ARM CPU. So we have ARM64 in cloud. So we say that there's no reason why we should just lift these embedded operating system middleware systems that automotive runs in ECU in cloud natively. We can do that because the way our data centers are organized in terms of compute is there's a lightweight hypervisor, it's called Nitro, that exposes the really very low-level functionality of the ARM cores. And you can even use these instances, these compute resources that we call instances, in a so-called metal fashion. So really accessing the bare metal of the ECU. So Graviton 3, for example, has 2 or 3, has 64 ARM, 64 cores. As you say, those are Neoverse cores. So it's not the typical Cortex, but the big bulk of instruction is anyway ARM64. So, and then you have extensions of this instruction set that can change from Cortex to Neoverse or other part, but that can be that part can be emulated, and you can even achieve, as we recently discussed in a tech talk with ARM, higher fidelity, implementing a specific ARM core on AWS very efficiently on Graviton. So to ARM virtual hardware, that's the name of the platform. But going back to the native part, we are loading up hypervisors, so we can even implement the full automotive stack from the hypervisor up. QNX hypervisor, for example, L4RE hypervisor and others. And then we implement a wide variety of embedded operating system, QNX, VxWorks, automotive grade Linux, Android, and so on, Red Hat in-vehicle infotainment system. Again, I already said VxWorks probably. And real-time as well. So real-time systems, Ubuntu real-time. We already just released the PR a few weeks ago with Ubuntu real-time. So even for real-time, kind of application, you can start to use the cloud to develop systems. And that's really helpful. We had customer, we presented at reInvent, Volvo Cars, presented the use case, for example, using QNX on AWS. And they were telling us and the audience that they were able to detect bugs that before they were able to get only through hardware in the loop rigs. And you see how you are shifting left the development, right? Because in automotive is very well known that you have to detect and fix the bugs as early as possible, because otherwise the cost is exponentially higher later in the process. So that was a very big validation of this approach, and we really see the customer reacting to that. You need those artifacts to implement SDV. Again, otherwise it's hardware defined, it's not software defined. So parity is really a key concept, and creating this continuum, this control plane from cloud to edge is relevant.
The consolidated architecture is there then. How do we deploy the software? Do we also change the way we are architecting the systems, right? That's also another part, right?
Yes.
Because you also mentioned a lot about shift left, but also collaboration on the cloud. So maybe automotive software developers could be segmented. So some part of the people could work on a specific part and some others would be working on the other parts. Also, if you have lightweight way of doing this delivery of software, it could be like streamlined, right? So I'm getting at the containerization part, right? So now you have the consolidated architecture, but also you shouldn't do it in a monolithic way. You should do it in a containerized way. Let's talk a little bit about that one as well.
Yes, absolutely. Yesterday I was in a customer workshop, and that was one of the main messages, saying don't think that you just consolidate the hardware and leave the software as it is. You take the software that is currently running in one of the cost-constrained ECUs right now, and you try to load it up on a consolidated ECU, it will just explode. That's bloatware ready to explode. So it won't work. You have to re-architect the software. Obviously, it's absolutely obvious, because the computer resources, the methodology, and the framework is totally different. That, by the way, doesn't mean to change developer, tooling and practices, right? So, for example, again, a QNX developer will continue to use Momentix IDE, that is the IDE used for QNX development. But the way this software is packaged, yes, needs to be different. It needs to be and go towards a microservice-based approach. It needs to expose APIs that enable decoupling of modules and clear interfaces between these modules. And of course, Autoware OpenAD Kit is exactly going in the direction. And it makes so much sense, because I developed and I helped to develop an autonomous driving stack in a previous startup in 2 companies. And the people that is involved in that kind of process have totally different background and mindsets and tools. For example, when you develop the perception stack, you have data scientists, you have computer vision specialists. They use tools like Jupyter Notebooks. They need wide access to data. They need labeling tools. This is totally different when you go on the planning and control part of the system. They use C++ code. They are controller engineers. They may use a Simulink to do part of the control. They need the virtual models of the vehicle. They use a synthetic simulation instead of real data. It's completely two different set of competences. And you don't want to give them a big blob as we were doing at that time of, I don't know, 80 gigabytes, and everybody was just playing in a single thing. No, you got to define these interfaces and this component, and to let the people collaborate on their part, improve that, and slot it in and upgrade it, so you achieve higher agility in the objectives. There's another aspect that is even inter-company collaboration. And this is going a little bit outside the open source part, but we released a very important demo with DSpace Electrobit a few months ago, where we implemented the full subsystem of the vehicle virtualized in cloud. Some of the containers, some others were native applications. And it was interesting because the three parties, so AWS, Electrobit, and DSpace, they were keeping their software in their accounts. So what we call virtual private cloud, so in their environment. And you just a customer, you have access to your VPC, nobody else have access to it, obviously. And to make the system communicate, we created the so-called VPC networking, VPC peering, so virtual networking between the virtual ECUs across accounts, and without sharing the IPs or the artifacts. And this is a kind of another software-defined implication of this revolution, meaning the software-defined supply chain and value chain that goes in bundle with re-architecting the artifact exactly in the way you described in this question, for sure. So super relevant aspect on multiple levels.
Thanks for reminding us the importance of containerization there. And also, now I think that's a good time that we jump a little bit on the collaboration between the auto.
Sorry, I have another quick note about containerization because it's relevant. Because, for example, I hope to do the same, by the way, for one of the next demo that we will have with OpenAD Kit. But last CES, we presented this demo that was deploying an embedded system through a container. And to do so, we used the two key technologies that I think are relevant to complement the discussion. One was derived from the Kubernetes domain. So you kind of update software like you are orchestrating a container in those kind of technology. And the second, we connected that with the other super important concept in SDV transition. It is infrastructure as code. That means that you use, for example, Cloud Development Kit or tools like Terraform or CloudFormation or Pulumi to write a script that defines your infrastructure, where in this exception, infrastructure includes the embedded devices on the field. Of course, the objectives of orchestration and infrastructure as code are different if you want to scale out a simulation in millions on the cloud, or you want to keep a container alive in the car, and we need to work on it. But that's super important element to cost optimize, to guarantee reliability, to guarantee security, and to adopt best practices in doing that.
I think also Robert touched on this a little bit because we have the kind of heterogeneous compute there, right? Because we are talking about automotive, it cannot be like the smartphone, so we need to be aware of the functional safety and that should have a kind of like a different angle there, but also
that's why we call it mixed critical orchestration, because the criticality levels of these containers and application depend on their functional safety criticality. And we have that responsibility in this sector, right? This automotive sector where if you mess up, somebody can get injured. So
that's important. Also, I mean, that's also relevant on the SOFI side because when you look at the architecture, right? It's based on the open standards, so the hardware manufacturers are getting aligned on the open standards, and on top there is some kind of like a middle layer, the orchestration. The SOFI's reference implementation is there, but also you can change it with a different hardware abstraction
Yes,
layer. It doesn't
of course.
necessarily have to be one a particular one. And then on top, there's
Yes.
the application side, right? And
Yeah.
Sophie's, the OpenAD kit is the Sophie's first blueprint. And Robert said the
Yes.
OpenAD kit is the poster child, which is true because it's the
Yes.
first one.
Definitely.
And the goal of the
No doubt.
OpenAD kit is to take the Autoware code base because it was monolithic until recently. So we actually split it there into different containers because if you want to move the entire monolithic thing over the air update, it's just not going to work. You just need to take it
Absolutely.
into little parts so you can actually. So it's also a bidirectional way, right? So you can push the data up and you can also push the validated functions and in container forms back to the edge. So everything is nicely streamlined. So looking at the Sophie architecture, there's also the mixed critical part there. So it could be a safety island there also. There could be the parts that doesn't require safety relevant things. And the orchestrator, Kubernetes is one of the examples, would be aware of which one is going to non-safety,
Yes.
which one is going to safe, so we make sure that the things are delivered to the right place. So
Yes.
nobody screws anything up in the process.
Absolutely. And for example, another example in there, a specific container needs to be run on a
Yeah.
specific OS in this. So there's always an interplay. So maybe the control requires real-time operating system. Perception, no, it's you run it typically on a Linux machine or other systems, but it's different kind of purposes. Plus, we can refer, for example, in the Sophie context, there's a very good job that LG Electronics presented about an orchestrator agent called Piccolo. It's very interesting. So you can have a lot of perception and artificial intelligence applications, for example, related to driver monitoring system. Some of them are critical. So gaze for attention detection,
Yeah.
it's mandated, right? So you must have your eyes on the road in level 2, level 3, some level 3 systems. But some others, for example, your mood while driving, that's not critical. That can be used to maybe just change your music in the car. And that is not critical. So the way you orchestrate these different kind of AI applications is very, very relevant. And in the idea is, you have resources, you just execute it locally. You don't have enough compute resources, you move the non-safety critical ones to a cloud execution, and you leave a priority to the safety relevant ones inside the vehicle itself. So you see how things become dynamic in that sense, and great work from the LG team, right? And we need to work on definitions, the way this is described as a system, the way this is deployed and orchestrated, monitored, made secure. So a lot of work to do, but the direction is the right one for
Yeah.
sure.
I mean, let's spend a little bit time on the how to collaborate, right? Because we shouldn't be when you look at the Sophia architecture, the application developer should just focus on their application because that's also what's important to the to the software developer, right? Why would you develop something on the foundational level? It should be shared among all the stakeholders. But you said in the Sonatus podcast, the no competition on the open standards because it doesn't make sense. We should focus on the value added differentiation, right? Because that's what the
Absolutely.
customer needs. That's what will make the customer happy. Let's stay on this a little bit and tell us why the open standards are really, really important for us.
Because it's totally. I think it's it's very dumb to compete on standards. You collaborate on standards because we have a very specific term, by the way, in Amazon in general and in AWS. In AWS, we one of the mantras that we have is we help to lift customers from their undifferentiated heavy lifting. So there are some kind of basic operation, user management, for example, in the AWS, providing security, making sure that the hardware is highly available, providing backups in some cases, all this kind of thing. Honestly, if you are a startup, if you are a company, are these really adding value to your value proposition in your product, in your unique selling proposition? They do not. And that's why a lot of startups are engaging with AWS, because they say, okay, this is taking me out completely the burden to think about this accessory aspects, because AWS is doing us it's doing it for us, and we can focus on the value prop of our idea, and we can innovate faster, right? Standard is the same thing. It's exactly the same thing. It's resolving the differentiated heavy lifting of some structural issues in the sector. So that's why we need the standardization of VSS from Covisa. That's why we need all these kind of measures from SOFRI, from Eclipse SDV, that really helps to standardize the way containers are orchestrated in a mixed critical situation. The hardware is abstracted, safety items are represented, and so on. This is it's not a complete arena. When you have this plumbing done, then you start the competition on top of it. And will win who has the best idea, who can innovate faster, who can propose the best value for the customers. But this is just a very important effort that needs to be done collaboratively as fast as possible in the best way possible in the interest of everybody. There's a good example of it, by the way. I can tell you a very specific example. In the agriculture sector. Agriculture sector was one of the first to invest on digitalization. All the OEMs invested in a technology called Isobus, coming from a standard called the 11783. That really produced a boom in terms of digital application, value for the farmers. They did a fantastic job to put together these plumbings, and everybody benefited for it. Customers first. So totally, and that's why it's important to really collaborate on these aspects and dedicate attention and do it fast and nicely.
Yeah. Yeah, I mean, when you look at the SDV ecosystem at large, we are seeing also a lot of existing players there, right? So they are now also coming together to work together to get the standards aligned and shared
Yes,
between all the stakeholders, including Eclipse SDV, Sophie, AutoSAR, and everything.
absolutely.
So we are also
Yeah,
seeing Covisa also. So I guess Robert also
yeah.
mentioned they share quite some percentage of the membership as well. You're also a part of Sophie and Eclipse SDV as well, right? So I think
Yes.
this open collaboration will really bring some benefits to the automotive ecosystem. Stefano,
Yeah.
at this point, let's talk a little bit about the OpenAD kit in general, right? Because we are preparing this nice demos to be shown at several locations at the CES, both at the show floor and also some adjacent events as well. And we are really, really happy to see the excitement around OpenAD kits. Um,
Yes.
what's your what's your take on the OpenAD kit? Robert said it was awesome, and it's become a poster child, and I'm really looking forward to see those live demos going out at CES.
Absolutely. I tell you one thing that even in our booth last time, we had this SDV vision kind of demo where we presented again orchestration and infrastructure as code using an example, and customers adopted that as their SDV vision as some customers. So I think that OpenID has a similar potential, right? So because again, it explains very well what are the some possible solutions and some issues that we need to work on, right? Because again, it's not just everything is
Yeah,
done. This is something you can adopt. Yes, it's something you can adopt, but it's something that we need to work on. There's a vision there, but to get from the vision to a real product on the market, there's work. And that's why we love really this collaborative approach, and all not just the developers that are involved, but the companies that are contributing to this open source initiative. Again, I told you we did already 2 hackathons in AWS a few months ago. I really hope that with the new year, now we have here in Santa
Oh yeah.
Clara a very awesome automotive lab. Uh, be happy, and surely we will work to host some hackathons, maybe once a quarter, something like that, in the automotive lab, to have the community of the Bay Area and beyond to participate. Uh, and by the way, going back to my example in agriculture, that was one of the reasons of the success of Isobus. They organized the so-called Black Fests. That was a fantastic event. They participated and organized a few of them. But where you all have all the different manufacturers, companies coming together and testing their systems all together. So, and that was again a great example of collaboration. And we should do just the same, right? So we have these hackathons. You have your you can take the perception coming from the OpenID Kit system, but maybe you want to integrate it with your planning and control because you have a specialized version for it, maybe not even for a vehicle, for a bus or another kind of application. And so on, create this dynamism, right? Because we really find the common language and the common way to work and provide value to a stack, right? That serves as a reference. So I think that's the value I see in OpenAD Kit.
Perfect. I think we should really work towards reinitiating those hackathons because I think we have the nice tools to do that. I don't know if you checked out Awesome. That's the end-to-end simulator. Now we actually
Yeah.
connected that to our planning simulator as well. So you can actually do the planning and you can see it in the Unity-based simulator, which is actually another demo at the CES for the Indie Autonomous Challenge. So we can, yeah, we can
Yes.
also, racing is
Yes.
also always bringing popularity to anything anyways.
Yes.
Okay.
Absolutely. Yeah, we sponsored the past edition of Indie Autonomous Challenge. So absolutely, totally understand that, and
Yeah.
there's a value for sure in there, right? So you think about the synthetic simulation, AV sim, that is a new thing. So great, fantastic, another big thing. We can't wait to run it on AWS. I think it's already running on AWS, at least in some kind of applications. But there's the data as well. So I think it would be, and this is a call to whoever is listening, but data is relevant as well for the
Yeah.
perception part, right? So maybe start to have a little bit of engagement in have some data sets that we can use in order to test better perception, start to calculate KPIs and work on that part of the tool chain as well. I think it's relevant as well. Yeah, again, it's there to have fun. Honestly, that's the nice
Yeah,
part.
you just mentioned a very nice thing because right after you, I'll actually planning to host CJ because the DevOps tool is going to make that possible, right? The MLOps and everything to
Yes.
improve the machine
Yes.
learning and other operations. Yeah, perfect.
That's
Yeah.
so relevant. One of the big things that we discovered working with a lot of partners, ISVs, especially in the automotive sector and SDV, is that, and the customer were totally asking for it, is the implementation of end-to-end use cases. An example of it, for example, at reInvent, we just presented an important collaboration with ITAS, where we integrated almost all ETAS tools in an end-to-end workflow. So you start a developer is modifying a model, and this modification is then committed, and this produces the artifact. The artifact are tested in other tools. Tac, 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 tac. There's a whole sequence, a whole workflow that happens in a CI/CD modern fashion, integrating traditional automotive tooling with modern CI/CD approaches. And this is super relevant because again, and that's why I love OpenAD Kit, by the way, because again, I had a lot of experience in autonomous driving. It's all about end-to-end workflows.
Mm.
So testing planning control, using this simulator, AWSim, how you do create a report, how you create a closed loop, what's the vehicle model, and so on. One workflow. And then you have the other for perception. You collect the data, you select which one needs to be labeled, you train, you validate, and then you continue the process. It's all about end-to-end workflow. So super relevant aspect.
Perfect. I think for this CS, we are going to be able to close that loop, at least for the simulation of, I mean, the functional validation of a planning module. But hopefully, in the next year demos in 2024, we'll try to also incorporate some of the perception and other parts as well, so
Yeah.
we can actually use the envelopes and everything else.
Yes.
Stefan, yeah,
Yeah, I think in next year it will be good to demonstrate the fact that, for example, to the
yeah,
synthetic simulation you can upgrade the as we are doing in the demo. We upgrade the planning part through a kind of a perception a workflow. You improve the perception part, and these containers are updated differentially, and everything just continues to work. I think that will be a good demonstration of the dynamicity and the microservice based approach. So that can be interesting.
perfect. So I'm looking forward to seeing you in person also at the CES on the show floor. We will have the demos in
Yes.
the AWS booth, at the Tier 4 booth, and also at the adjacent Cobisa event. Stefano, it's been a pleasure for me to host you in the Autoware podcast, and thank you for joining and sharing these insights. And hoping to see you again in some of the next episodes as well, with some kind of upgrades and new topics to discuss as well.
Yeah. Yeah, some of my colleagues, Yuki, of course, has been involved. That he couldn't be here, but it will be great to have him as well in one of the next episodes or opportunities we will have. I'm sure we will have other opportunities to chat together. Thank you so much for the invite, Samet. Really appreciated it. Again, we love this initiative. We are eager to contribute and invite to all the audience. If you have any kind of feedback, if you want to engage, reach out. Hopefully, we'll see you at CES if you're there. If not, and you are in the Bay Area, let me know. We will have a demonstrator here live after CES. So I'll be happy to engage, and it's not just a one spot thing. It's something that we want to invest on for the next months and
Perfect.
years.
Thanks, Stefano. Talk to you soon again. Take care. Bye.
Thank you. Bye bye.